Hey everybody, welcome back to more College Algebra. College Algebra the sequel? I don't know, something like that. Anyway, this is chapter 2, so it is kind of College Algebra the sequel. Anyway, we'll be dealing with chapter 2 for a while, basics of functions. Chapter 2, all about functions. We will skip around a little bit in order to make things work well, but we will do the first couple of sections here. Like many of our videos, this will be broken up into two smaller ones. This is part 1 for section 2.1, the basics of functions, and then we'll talk about the graphs of the functions in the second part. Okay, so section 2.1 has all this content in it, a whole bunch of stuff, and so for this video we're going to deal with the first 4, finding the domain and the range of a relation, talking about what the difference is between a relation and a function, and then looking at the equations of functions and evaluating them. And then we'll deal with graphing functions later in the next video. Okay? So, a relation is any set of ordered pairs. And another way to talk about that is a relation is any type of way to relate two different sets to one another. Okay, so we have relations all the time. Like when I get your class list, that's a relation because it has your name and your 9,000 number on it. Okay, so for example, that's an example of a relation there. Okay, the domain is the first component, and the relation's second component is called the range. All right, and so this is the basics of a relationship, but relations don't have any real rules to them other than just there's a set of ordered pairs. Okay? So when you're looking at these guys here, the domain of the relation is the first number in the set in the ordered pairs. That's the domain, all those numbers, and then the second numbers, those are all the range values, and you'll see that in this case they're all different. Okay? But they don't have to be. For relations, they do not have to be different. 0 could be tied to more than one number. 10 could be tied to more than one number. It's fine. It's no big deal. I mean, it's kind of like having a Coke machine, right? And you have more than one button for Coke. All right, that's fine. That's no big deal. However, in order to be a function, all right, a function has the same idea where we have this domain set and a range set. We're going in one direction now, and each element in the domain corresponds to exactly one element in the range. To go back to my Coke machine example, you might have more than one Coke button, and if you push each of those buttons, you still get out of Coke. So all 3 of these buttons here, 1, 2, and 3, they all go to Coke. Okay, but what you don't want to have happen is you cannot have one button that sometimes gives you a Coke, but then sometimes gives you a Sprite. That would tick you off, right, if you pushed the Coke button and got out something you didn't ask for. So that's not a good machine, right, and that's not a function. A function is when each element of the domain corresponds to exactly one element in the range. So this is what we don't want when we're talking about a function. Okay? So here's an example where we have this relationship here. Okay? What can you tell me about this relationship? Is it a function? Well, we have 4 different x values, and so each x value is related to a y value. The y values can be the same. That's okay. It's okay if you push the 6 and the 8 and you get a 5 each time. That's not a problem. But what is a problem is if you were to have the same x giving you different outputs. Okay, so the solution is, since no 2 ordered pairs in the relation have the same first component with different second components, it is a function. So just to finalize it here, what's your domain? Your domain are the numbers 1, 3, 6, and 8. And your range, what's your range? Your ranges are the numbers 2, 4, and 5. Your range can have fewer things than the domain, but it can't be vice versa. You can't have fewer domain elements than the range if you're a function. Okay? So y'all pause the video and take a look at this one, and you guys decide yes or no, is it a function or not? And if yes, then great, and if not, tell me why not. Okay, so pause the video for a moment And let's figure this out. Okay, so what's the domain of this relationship? We have a 1, we have a 3, and we have a 5 as our domain. We have the range. The range is 2, 5, 7, and 9. All right, I just talked about the fact that your domain can't be smaller than your range if you have a function, but specifically the number 1 goes to 2, but 1 also goes to 7. That's not allowed. Sometimes I push the 1, I get a 2. Sometimes I push the 1 and I get a 7. That's not a good functioning machine. So it's not a function. Because x equals 1 gives us y equals 2 or 7. And that's not okay. Not a function. Okay? All right. Now, functions as equations, we will start writing functions, and we've seen these before, right? Y equals 2x plus 9, right? We've seen this as a function. Well, if it is we've seen this as an equation, right? If it is written as a function, then you can solve it for y. If you can't solve it for y, then it's not a function. So here's an example of one that is not solvable for y. If you have x squared plus y squared equals 1, then we subtract x squared from both sides. You're left with this. And then if you take the square root of both sides, you get y equals plus or minus. Remember, when you take the square root of both sides, you get plus or minus. And so here, as an example, right, if I plugged in x equals 0, what would you get? You would get plus or minus the square root of 1 minus 0 squared, which is plus or minus the square root of 1, which is plus or minus 1. You get two answers for 1x. And that's not allowed. That's not a function, because for an x, you plug an x in, you can get two y's out. Okay? So that equation does not define a y as a function of x. Okay? Now, hopefully you understand the basics of functions, but the good part is mathematically we don't let it to chance. Okay? So when we have a function, we write something like f of x instead of y. So f of x replaces y in a function. So the example I wrote on the last page here of y equals 2x plus 9, we would no longer write it like that because this is a function. We write it as f of x equals 2x plus 9. And that means the same thing as this. They mean the same thing. But when I write with functional notation, that tells me two things. One, it tells me that I have a function. I can't write f of x if I don't actually have a function, so that's handy. But the other thing is that it gives me a way of notating things kind of by shorthand. It's a mathematical terminology, okay? And so to show you an example of that, here's a function f of x. F of x is equal to x squared minus 2x plus 7. And they want you to evaluate f of negative 5. Now, the book doesn't teach it this way, but I'm going to show you, ideally, if I could write a function, if I could make algebra work without letters, I would. Okay, I'm sure you would too, actually. But in this case, what happens is when I have a f of x, x is holding a spot. So if I have f of blank, the blank is being squared. I'm subtracting 2 times the blank, and then I'm adding 7, right? So if you want to find f of 5, what does this actually mean? This means find y when x is minus 5. So the x of minus 5 is being plugged in here, and when I drop negative 5 in here, guess what? It gets dropped in all these blanks. You fill in the blank with the same number everywhere. So if they said find f of 7, you would plug a 7 everywhere. If you said f of 1/2, you'd plug a 1/2 everywhere. And then you do arithmetic, and you got to be careful when you do this. Negative 5 all squared is positive 25. Negative 5 times negative 5. Negative 2 times negative 5 is positive 10. And then plus a 7, and 25 plus 10 is 35, 42. So f of negative 5 is 42, and what that means is that on the graph, we'll talk about the graphs next time, but on the graph of this function, the point negative 542 is a point on that graph. So the points on the graph of this function correspond to the values that you get out when you plug in x's and figure out what the y's have to be. Okay? So we'll talk more about the graphs next time, but I want you to focus on evaluating a function. And so if we go to the next problem, notice f of x is now different. I've called it something different. It's 4x minus 3 divided by x. I want you to evaluate f of negative 3. Pause the video, take a minute, figure that out, and we'll come right back to it. Okay? So again, I'm going to do f of blank equals 4 times blank minus 3 divided by blank. And then I'm going to take this negative 3, I'm going to plug negative 3 in all the blanks, every one of them. Okay? So that's step 1. And now you just have to evaluate, just doing arithmetic. All right? So f of minus 3 is equal to negative 12. 3 divided by 3 is 1. Negative is positive because negative 12 plus 1, so that's negative 11. So f of minus 3 equals negative 11. And that's the answer you should have gotten. Okay? So, a simple basic introduction into functions and their notation. Come back for part 2, where we will take a look at the graphs of functions and how those look different than the graphs of just general relations. Okay? Thanks.